Cross-tabulation and segment comparisons in market research. In this lesson, we will use real survey data to compare customer segments and find valuable patterns. Businesses need to understand how different customer groups behave and feel to make informed decisions. You will learn how to create cross-tabulations, compare segments, and draw actionable insights from the results. Running the cell now. We import pandas for data analysis tasks. We import NumPy for numeric operations and reproducibility. We import OpenML to download real customer datasets from the public OpenML repository. We import the Warnings module to manage warnings during analysis. We ignore warnings so they do not interrupt our market research workflow. Running the cell now. Core concepts. What is cross-tabulation and segment comparisons? Market researchers segment customers to compare behaviors, satisfaction, and responses. Cross-tabulation is a core method. It groups data by two or more variables to observe interactions. Customer survey data often includes demographics, responses, and scores such as satisfaction or NPS. Beginners sometimes treat survey scores as continuous when they are actually ordinal, or forget to handle missing values. Segment comparisons must use correct groupings, and always interpret results with business meaning in mind. Running the cell now. We will start by loading a real customer satisfaction survey dataset available on OpenML. Previewing the data helps ensure that it is appropriate for segment analysis. We access the dataset from OpenML using its unique ID. We load the data into a pandas data frame for easier manipulation. We print the shape of the data frame to check the dataset size. We print the top 3 records so we can visually inspect some customer data. Running the cell now. This output shows the initial glimpse of a real customer satisfaction survey with 7,043 rows and 20 columns, capturing demographics, service features, billing, and churn status. Notice the mix of categorical variables like gender and contract type alongside numeric charges, all crucial for cross-tabulation to reveal how different segments behave or churn. This setup emphasizes the importance of understanding each column's role before grouping or comparing segments in market research. Practice: look for demographic columns like gender, contract, or seniority in the preview above. Understanding the size of each segment is essential before creating crosstabs. Here we count the number of customers in each gender segment. We create a frequency table for the gender column to see how many customers are in each group. We print the counts for each gender to review the distribution. Running the cell now. This output shows the frequency counts of survey respondents by gender, including both males and females with nearly equal group sizes. Notice the balanced segment sizes, which is crucial for fair comparison in later analyses. This step exemplifies how cross-tabulation starts with correctly grouping and quantifying categories before deeper segment comparisons. Try this: count frequency for another categorical column like contract or senior citizen. Cross-tabulations help us compare churn rates between genders. This is a fundamental market research analysis to identify if churn is related to gender. We use pandas crosstab to create a table comparing gender and a churn. We print the resulting crosstab to view the segment comparison. Running the cell now. This cross-tabulation shows the count of customers by gender and whether they churned, highlighting similar churn numbers across males and females. Notice the clear segmentation of data into groups, allowing us to directly compare churn behavior by gender. This illustrates the core concept of cross-tabulation, breaking down survey or customer data into meaningful segments for straightforward comparison. Can you interpret which segment shows a higher churn in your crosstab? Percentages are easier to interpret than raw counts, especially in business reporting. We will calculate the percentage of each gender in each churn category. We create a crosstab and normalize by column for percentage values. We multiply by 100 and round to display percentages cleanly. Running the cell now. This cross-tabulation shows the percentage distribution of gender within each churn category, calculated column-wise. Notice that the proportions of males and females are nearly evenly split between customers who churned yes and those who didn't no. This output highlights that gender alone may not strongly differentiate churn behavior, emphasizing the importance of examining multiple segments and variables for meaningful insights. Practice: compare these percentages to see which gender segment has greater churn. Now we examine if contract type is related to customer age, senior status. This can reveal product preferences or service adoption in different groups. We make a crosstab between senior citizen and contract columns. We print the crosstab to see the relationship between these segments. Running the cell now. This cross-tabulation shows the count of customers segmented by their senior citizen status and contract type. Notice that non-senior customers, 0, have substantially higher counts across all contract types, especially month-to-month, compared to seniors, 1. This highlights how grouping by demographic and contract variables reveals distinct customer segments for targeted analysis. Try swapping the axes and compare patterns. It is important to check for missing values before aggregating segment data. Missing values can distort your calculations and lead to wrong conclusions. We count missing values in the dependents column to see if any segments are incomplete. We print the number of missing values to assess data quality. Running the cell now. This output confirms there are no missing values in the dependents column, which is crucial before running cross-tabulations involving this variable. Ensuring completeness helps avoid biased segment comparisons and misinterpretations, reinforcing the lesson's point about properly handling missing data for accurate market research insights. What would happen if you ignored missing values during segment comparison? It is common to turn numeric variables like tenure into categorical segments for analysis. Let us group customers into tenure segments to compare their behaviors. We define bins to group tenure in months into categories. We assign descriptive labels to each tenure group. We use PD-cut to segment the data and create a new column tenure group. We print the original tenure and new group for the first 5 customers to check correctness. Running the cell now. This output shows how the tenure data is grouped into meaningful segments labeled 1YR, 1-3 years, and 3-6 years. Notice how individual tenure values are categorized into these discrete groups, which is essential for comparing customer behaviors across tenure segments. This step prepares the data for cross-tabulation by creating clear, ordinal groupings that reflect different customer experience stages. Practice: can you try more refined tenure segments? Let us add an additional dimension to our crosstab for deeper segment analysis. This approach reveals interactions between contract type, churn, and age, senior status. We create a crosstab with 2 levels of row indices for contract and senior citizen, and columns for churn. We print the result to analyze the combined effect of these segments. Running the cell now. This cross-tabulation shows how churn varies by contract type and senior citizen status, revealing key patterns in customer retention. Notice that month-to-month contracts have the highest churn counts, especially among senior citizens, while longer contracts generally show lower churn rates. This output highlights the importance of segmenting by multiple variables to uncover nuanced interactions that can guide targeted retention strategies. Try to spot any high churn segments that stand out. Besides crosstabs, aggregation by segment using Group B is key for comparing averages. Let us find out which contract segment pays more on average. We use Group B to segment data by contractor and calculate the mean and monthly charges for each. We print the results to compare spending between contract groups. Running the cell now. This output shows the average monthly charges for customers grouped by their contract type, highlighting that month-to-month contracts have the highest average charges. Notice the clear trend: longer contracts tend to have lower average monthly fees, which reflects pricing incentives common in customer segmentation. This illustrates how cross-tabulation helps reveal meaningful differences in behavior across segments, in this case, how contract length impacts subscription costs. Practice: group by tenure group or other customer segments to compare spending. We switch to a real marketing campaign dataset to show crosstab analysis for campaign response rates. Analyzing segments like marital status helps marketers target more effectively. We load the marketing dataset from OpenML. We assign meaningful column names for easier business understanding. We create a crosstab between marital status and campaign response. We print the results to study differences among customer groups. Running the cell now. This cross-tabulation groups customers by their marital status and their response to a marketing campaign, showing how many responded with 1 or 2. Notice that married customers compose the largest segment overall, with the highest counts in both response categories, which highlights the importance of segment size when interpreting results. This illustrates how crosstabs reveal interaction patterns between demographic segments and campaign outcomes, a key step in meaningful segment comparisons. Which marital segment shows the highest number of responses? Rates and percentages are more actionable than raw counts in marketing decisions. We will normalize the response rates by marital segment. We normalize the crosstab by rows, each segment. We print the percentage of responses by marital status. Running the cell now. This table shows the normalized response rates by marital status, where each row sums to 100%, allowing clear segment comparisons. We see that singles have the highest rate of response category 2, 14.9%, while married respondents show the lowest, 10.1%. This illustrates how cross-tabulation reveals meaningful differences in behavior across customer segments by correctly grouping and normalizing the data. How would you interpret the highest and lowest rates for targeted marketing? Combining segments like education and marital status provides even deeper insights for campaign planning. Let us look at response patterns across these combined customer groups. We use a multi-index crosstab of education and marital status against response. We print the crosstab to show the response breakdown by group. Running the cell now. This cross-tabulation groups customer counts by both education level and marital status against their response categories, 1 or 2. Notice how the majority responses are clustered in response 1 across all segments, with married customers consistently showing higher counts, especially at the secondary education level. This illustrates how segmenting by multiple variables reveals interaction patterns that inform targeted marketing or research strategies. Which group appears to be most responsive? Net Promoter Score, NPS, surveys are widely used to segment customers and assess loyalty. Let us generate and categorize NPS data into standard groups: detractor, passive, promoter. We set the random seed for reproducibility. We simulate a 500-row NPS survey dataset with random regions and scores. We categorize NPS into 3 business segments. We print the first 5 records showing both the score and its category. Running the cell now. This output shows the original NPS scores grouped into meaningful categories: detractor, passive, and promoter, based on defined score ranges, alongside customer regions. Notice how scores from 0 to 6 are classified as detractors, illustrating the key step of converting numeric survey responses into ordinal segments for comparison. This segmentation sets the foundation for cross-tabulation to analyze how NPS categories vary by demographic groups like region. What does each segment, detractor, passive, promoter, mean for the business? Businesses want to compare loyalty across regions, so we cross-tabulate NPS categories by region. This reveals if customer sentiment differs by geographic market. We run a crosstab for region versus NPS category, normalizing for row percentages. We print the table as percentages so management can spot loyal or at-risk regions easily. Running the cell now. This cross-tabulation shows the distribution of NPS categories within each region, expressed as percentages summing to 100%. Notice how the South and East regions have the highest proportion of detractors, while the West stands out with the largest share of promoters. This comparison helps market researchers identify regional differences in customer sentiment, highlighting where to focus improvement efforts. Which region has the highest share of promoters or detractors? Knowing the age profile of highly satisfied customers helps with targeted loyalty programs. Here we analyze the average age of promoters within each region. We filter the NPS data to promoters and group by region to calculate the mean age. We print the result to profile loyal customers. Running the cell now. This output shows the average age of promoter customers within each region, highlighting how customer segments can vary demographically. Notice that the East region has the highest mean age, which helps illustrate how cross-tabulation and filtering combine to reveal meaningful segment-specific insights in market research. This reinforces the importance of grouping by relevant variables to compare customer behaviors accurately. Practice: try the same for detractors or overall population. Analyzing purchase volumes by country and month enables trend and segment analysis in international e-commerce. Let us cross-tabulate the count of transactions by country and time period. We load a real online retail dataset. We ensure the invoice dates are properly formatted for time-based analysis. We compute the year-month period for each transaction. We create a crosstab of purchase counts per country and month. We print a subset for readability. Running the cell now. This output shows a multi-way cross-tabulation counting transactions by country and month, revealing seasonal trends and varying customer activity across regions. Notice how some countries like Belgium maintain consistently high purchase counts, while others like Bahrain have sparse activity, highlighting important segment differences over time. This aligns with the lesson's focus on using crosstabs to compare behaviors across multiple variables and time periods for deeper market insights. How does seasonality differ between regions or countries? Calculating segment shares helps reveal differences in churn rates for each contract type. Let us express churn outcomes as a percentage of each contract group. We create a crosstab normalized by rows, showing churn rates within each contract segment. We print the result as percentages for easier business interpretation. Running the cell now. This output shows the percentage distribution of customers who churned or did not churn within each contract type, normalized by row, contract, totals. Notice how shorter contracts, like month-to-month, have a much higher churn rate, 42.7%, compared to longer contracts, highlighting important segment differences. This reinforces how cross-tabulation helps market researchers compare behaviors across key customer groups for actionable insights. Which contract type appears most at risk for churn in this analysis? Sharing analysis results with stakeholders or decision-makers is vital. Exporting crosstabs to Excel lets business leaders review and use your insights. We compute a crosstab of contract types and churn outcomes. We save the table to an Excel file for stakeholders to access. We print a confirmation message. Running the cell now. This output confirms that the cross-tabulation of customer contracts against churn status was successfully saved to an Excel file for easy sharing with stakeholders. The saved table will allow market researchers to clearly compare churn rates across contract types, supporting data-driven business discussions. Exporting crosstabs is a practical step to disseminate insights beyond coding environments. Let us open the exported Excel file to review the contract churn crosstab with your team. Try customizing the export to include more dimensions as needed. Watch our channel for hands-on tutorials on reporting and dashboarding. Now we demonstrate safe error handling using a temporary copy of the dataset. First, we create a copy of the original marketing data frame to avoid modifying it. Next, we manually insert a missing value into the response column for demonstration. We then begin cleaning the response column. We reference the response column inside the temporary data frame. We replace missing values with the label unknown. We convert the column to string format for consistent display. We close the transformation block. Next, we create a crosstab between education and the cleaned response column. Finally, we print the crosstab to observe how missing values are handled. Running the cell now. This crosstabulation shows counts of survey responses by education level after safely filling missing responses with unknown. Notice how this handling prevents missing data from causing errors, ensuring every respondent is counted, even if only one tertiary entry is labeled unknown. This reinforces the lesson that proper missing value handling is essential for accurate segment comparisons and reliable insights. Using a temporary copy ensures that demonstrations do not permanently alter the original dataset. This is a best practice when teaching error handling in real-world data workflows. Typing mistakes in column names are a common error in segment comparisons. Here we show how to trap mistakes and guide users to the correct column. We deliberately use a wrong column name in Group B. We catch the resulting error and print a helpful message. This approach prevents workflow interruption and supports self-correction. Running the cell now. This output highlights a common mistake when grouping data by a non-existent column, resulting in a key error. The code's intent is to emphasize careful column name checks before cross-tabulating, ensuring accurate segment comparisons. Always verify your dataset's columns to avoid errors and maintain meaningful groupings. It is a mistake to average categorical survey responses without checking data types. Let us demonstrate this common issue by attempting to average a Likert channel column. We try to compute the mean of a column that is probably not numeric. We catch exceptions and print a business tip warning. This saves analysts from producing invalid insights. Running the cell now. This output shows an error when attempting to calculate the mean of the online backup column, which contains categorical responses like yes, no, and no internet service, not numeric scores. It highlights the lesson's point that cross-tabulation and segment comparisons require careful handling of survey data types. Treating ordinal or categorical survey variables as numeric can produce errors or misleading results. Always check and pre-process data to match the intended analysis. Constructing indexes provides an easy-to-use metric for business users. Here we build a churn index comparing the risk between seniors and non-seniors. We normalize the crosstab to row percentages. We calculate a derived metric comparing churn to non-churned customers. We print the churn index for each senior status group. Running the cell now. This output shows the churn rate ratio for two customer segments, non-seniors, 0, and seniors, 1. Notice how the churn index for seniors, 0.71, is more than double that of non-seniors, 0.31, highlighting a clear difference in behavior between the groups. This underscores the value of cross-tabulation for creating meaningful segment comparisons that inform targeted business actions. How could you use this index in your business reporting? Visualizations make segment disparities clear for business audiences. Here we create and save a bar plot of churn rate by contract type. We import matplotlib for data visualization. We plot the row-normalized crosstab as a stacked bar chart for each contract. We set chart title and axis labels for business clarity. We add a legend to distinguish churn status. We use tight underscore layout to avoid label overlap. We save the figure as a PNG image for sharing. We close the plot to free memory. We print confirmation of the saved plot. Running the cell now. This output confirms that the churn rate by contract type has been visualized with a stacked bar plot, showing proportions of customers who churned versus those who stayed. Notice how this visualization helps stakeholders quickly compare churn behavior across contract segments, making complex cross-tabulated data easier to interpret and support business decisions. The code's intent is to communicate segment differences clearly and effectively. Let us open the saved bar plot and visually compare churn across contract segments. Try visualizing other segment comparisons from this lesson. Subscribe to our channel for more crosstab and dashboard tutorials. Trend analysis adds powerful context to segment comparisons over time. Let us attempt a crosstab of churn over survey months, if available. We compute a simple crosstab of contract type and churn. We check if the invoice date exists in the data frame for time-based trend analysis. If available, we create a year-month column for time series. We crosstab churn counts by month to look for changing patterns. We print a preview of churn over time. If dates are not available, we print a message indicating so. Running the cell now. This output shows a key practice in crosstab analysis, verifying your data before proceeding. Since the de-invoice date column is missing, the code rightly stops instead of producing misleading trends, highlighting the importance of validating time-based segments before analyzing churn patterns over months. This safeguards the accuracy of segment comparisons and reinforces clean data checks in your analysis workflow. End-to-end example, from raw data to customer insight. We will load NPS survey results, cross-tabulate to compare loyalty by region, and give an actionable recommendation. Segmenting and cross-tabbing lets us focus business resources where they matter most. This is how market research informs better products and services. Running the cell now. We will analyze the NPS data to compare regional loyalty and produce a clear business takeaway. The segments with the most promoters and detractors point to strengths and improvement areas. We generate a crosstab of NPS category by region, showing row normalized percentages. We print the table as clear business metrics. We identify the top region for loyalty and the most at-risk region by their promoter and detractor shares. We print out these insights for practical business action. Running the cell now. This output shows the percentage breakdown of NPS categories by region, revealing that the West has the highest share of promoters, indicating strong customer loyalty there. In contrast, the South region has the largest proportion of detractors, signaling potential customer dissatisfaction. By segmenting this data, the code highlights where to target improvements for maximum business impact. Based on these findings, where should the business focus its customer success efforts first?